Hello, today we're going to learn how to create a DOP simulation in Houdini. And DOP stands for Dynamics Operator. So let's jump into Houdini. We are going to create an effect similar to this one. So let me first of all delete this setup and let's go over it from the beginning. And we will start with this SOP network we did in the first lesson. Okay, so there is one thing I want to add first of all to this setup, and that is velocities. So initially we had only the position, but for simulation it is also nice to have velocities. So to create this, I added a trail node, and here change the result type to compute velocity, and that will take the difference in the point positions and calculate the velocity for each point. And we can also visualize this using this velocity icon here. So this is our starting point. So let's begin with creating a DOP network. So press tab and type DOP, and I will call this my DOP. And then jump into this network and delete all the nodes because we're going to create it from scratch. So the very first thing you need in a DOP network is an object. So press tab and type empty object. And this is the container for the simulation information. And we can view this from the geometry spreadsheet. And you can see here we have now absolutely nothing yet. So let me just go to the timeline and reset this. Okay, you saw that we had some cached information, so I'm going to go back up and select the DOP network and press P. And here go to cache and uncheck cache simulation. So we are sure we have the actual information shown and no cached information. Okay, so here back into the DOP network. You can see we have an empty object, and that is apparently called obj0. And we want to call this, say, just object. And to make this the name, let's press P and change the object name to $OS. And this stands for operator string. So this will take the name of the operator and use this as the object name. And you can middle click here to see that it is replaced with object. Okay, so now if you look in your data view here, you can see that we have an object. And this is a sim object, and it has some parameters. Okay, so the next thing we will need is a multi-solver. So press tab and type multi and select multi-solver, and then connect the object to the input of this solver, and then select this solver to be the output. And we still have some cached information, so go back to the first frame to clear the cache. And here you can see now that we have a solver that is a sim solver multi. And also we have some relations and relationships, and we don't need this because this is not going to be interacting with any other object. So just select the multi-solver and press P, and here uncheck make objects mutual effectors. And now you can see that this will actually remove some information that we don't need. So this is a very minimal DOP simulation that does absolutely nothing. And we can build upon this to create the simulation we want. Okay, so let's start and add a SOP solver. So press tab and type SOP solver. And then connect this to the multi-solver. So the multi-solver takes several other solvers and run these in the order they are connected. So now let's go inside the SOP solver and delete all this trash here. And now we want something as a result. So let's begin to just bring in the animated points we had from lesson 1. So press tab and type merge and select object merge. And this is used to bring in another object. And if you press P, then you can select the object here. So we're going to my SOP and the out node and accept. And now you can see here in the data view that it is filled with these moving points. So let's see what this will give us. If you now go to the scene view and run, you can see we have a simulation that just copied the animated points and does nothing else. So the next step is to use this as a source to emit points. So actually for each frame it will take the new points and add these to the existing points. So it doesn't just overwrite the old data, but it adds new points as it runs. So let's go to the SOP solver, and we need to bring in the data from the previous simulation step. And for that we can use press tab and type DOP Import. And here press P for the parameters, and the DOP network is the dot. That means go up one level and select that DOP network. And that is this network. And for the import style, we're going to fetch the geometry. So the geometry is this kind of SOP information. And let's then, we don't need to add any path attribute. And let's remove the point velocities, and let's try not to trigger the simulation. Okay. So we have the old data and the new data. So let's merge these two together. Press tab and type merge. And then connect the previous frame information with the newly brought in animated points. And select this as the output. And let's see what we get now if we go back to the simulation and run this. So you can see that it keeps the old points and adds new points each frame. And we also want to animate these points or simulate these so that they move with the velocity. So let's add an integration step inside the SOP solver. So here press tab and type Attribute Wrangle. Attribute Wrangle. And this we explained in detail in the last lesson, so we can just use this without thinking too much. So connect this and press P, and here we can type VEX code. So to make an integrator, we need to use just basic physics law. So let's say we have a vector acceleration equal in the x component 0 and minus 9.8 in the y direction. And you can see here the y is this axis, and then 0 in the z direction. So this is basically just a gravity. And we also want a delta time. So let's say float dt equals at time inc. And if you watch the previous lessons, you will understand what this means. And next, type the formulas. So the velocity at v plus equals delta time times acceleration. And the position, so at p, the big P, plus equal delta time times velocity. So this will basically do a physics simulation using the velocity of the points. And the V, you need an @ mark to use the auto binding as explained in the last lesson. Okay, and let's call this integrator so we know what it does. And let's see the result of this. So go up to the DOP network and run. And now you can see that we have a simple simulation that we made completely from scratch using only atomic DOP nodes. So now you learned about DOP dynamics operator. I hope this was helpful, and see you next time. Over and out.